Alright, so this is going to be take 2 this morning. Sometimes I just can't get started with my lectures, and usually once I get into my lectures I'm not that displeased with what I do, but a lot of times I just don't start my lectures that well, and I'll record for like 5 minutes and then I'll stop and start over, and that's what's happening this morning. This section has some grungy computations that our TI-83 or 84 calculators can do, and it'll save us a lot of grunge. So you want to make sure to have your TI-83 or 84 calculator for this section, as well as for 3.5 and 3.6. So in section 3.3 we studied mean, median, mode, and mid-range, and these are all averages. The only word problems that we did in section 3.3 focused on the mean, and that's probably the most common average to use when we're speaking of averages. You know, more often than not we're speaking of the mean. And in this section we kind of want to dig a little bit deeper into the data and describe how spread out the data is. Two sets of data could have similar means but can look very different. If you glance at the data and you can compute the means might be exactly the same or real close to each other, but just by looking at the data you might sense that one group of data is really homogeneous and all the numbers are kind of alike, and maybe the other set of data is more heterogeneous and the numbers are really spread out. And in this section we're going to learn two concepts. The big concept is standard deviation, and a standard deviation is just a number that's associated with a group of data that describes how bunched up or spread out the data is. And knowing the standard deviation, if you're asked to make some decision about a group of data, might help you out. If you take a statistics class, almost every decision you make in a statistics class is going to hinge on what the standard deviation is. You'll compute the standard deviation, then you'll do some sort of z-test, f-test, student t-test to help you decide if your decision is statistically sound. But this is by no means a statistics class, and we'll maybe use the standard deviation to make a kind of guess kind of decision, but we're not going to implement any of the tools of statistics that involve standard deviation to make decisions. That would take it's a whole class. So we're just going to barely touch on the concept. So this next couple pages is supposed to help us understand why standard deviation, or how spread out or how bunched up a group of numbers, why might it be important to study. So I made up a scenario here with two fictitious companies, Company A and Company B, and both the companies make airplane engines, and both the airplane engines cost the same price. Companies A, their engines last 1,000 hours, their average life is 1,000 hours, and Company B, for the same price, has an engine and it only lasts 950 hours before they fail. So if you look at this just on the surface, if I had no other information and I was going out to purchase an engine, well, they cost the same, so that doesn't seem to be an issue. And Company A's engines last 1,000 hours, Company B's last 950 hours. Why wouldn't I choose Company A's engine? It just seems like it costs the same and it lasts longer. Why wouldn't I use it as opposed to Company B's? So that, if that's all the information you had, it would seem like that's the best decision to make. So I extended this problem, and that extension is supposed to make it seem like, well, maybe Company A's engines aren't the best. And so this is completely fictitious, but it's supposed to design to illustrate the concept of standard deviation. So I said, what if Company A's engines, they do have an average lifespan of 1,000 hours, but to get that average lifespan of 1,000 hours, half of the engines last 15 hours, 1,500 hours, and the other half lasts 500 hours. That would make an average of 1,000, because if one is 500 and the other half is 500, the other is 1,500, those will average out to 1,000 hours for life. So if you bought one of the Company A's engines, there's no guarantee that you're going to get the good one that lasts 1,500 hours. You could get the one that only lasts 500 hours. So buying companies A's engines, it's a bit of a roll of the dice, because you can be either extremely displeased or really happy. So but half the people will be really unpleased, half the people will be really happy, but their engines do last on average 1,000 hours. And then I made company B's engines a little, so that would be more heterogeneous. Their lifespans are really spread out amongst the mean. Well, if I took the company B and its engines don't last near as long, 50 hours later, less, but what if for company B, half their engines last 975 hours and the other half lasts 925 hours? So it has a lower lifespan, but if you're buying company B's engine, you more or less know what you're getting. It's going to last 900 and some hours, regardless if you have, a quote-unquote bad engine or an exceptionally good engine. When you're buying from company B, even though the engine doesn't last as long, there's less risk involved in purchasing company B's engine. You kind of know what you're going to get. So maybe given those two sets of information, it might make you make a different decision. Maybe even though A's engines last longer on general, you might choose company B's just because you want that certainty of lifespan as opposed to the rolling the dice with company A's. So this is our scenario. And then if you were in a company and you were wanting to make a decision and you wanted to justify your decision, well, it's probably nice to have some numbers to back up your decision. And standard deviation is probably the most common number to explain deviation in the data, and so we'd probably use that for one of our argument for one engine as opposed to another. And then there's another concept that's gonna maybe come into play in this section, but a little bit less so, and that's the concept of range. In the last section, we did something called mid-range, which feels like it should be the same as range, but it's not. Mid-range is the lowest plus the highest over 2, and it's an average, because when you're dividing you get an average. And it doesn't really tell you how spread out the data is, it just tells you about the middle of the data. In this section we do something called range, and range isn't an average, it's a measure of how spread out the data is. And you would think companies A would have a higher range because its engine lives are more spread out than company B's. And simply, the range is just the difference between the highest and the lowest values. So for company A, for their engines, their highest engine life is 1,500, the lowest engine life is 500 miles. So the range of company A's engines is 1,000 miles. Company B's, its longest life is 975 hours, its lowest life is 925 hours. The range is the difference between the highest data point and the lowest data point, and its range is 50 miles. Now, if we did mid-range for company A and mid-range for company B, so if I did mid-range for company A, the least miles that you'd get from an engine is 500. The most miles you'd get from an engine is 1,500. In mid-range, you add the highest plus the lowest and divide it by 2. This would be 2,000 over 2, which is 1,000. And if I did the mid-range for B, the lowest engine life is 925 hours. The highest engine life is 975 hours. And if I broke out my calculator to do this, I'd get 1,900 over 2, which is 950 hours. So mid-range is an average. In fact, it's the same as the mean for these engines. That doesn't tell me that the life of A's engine is much more spread out than the life of B's engines. But the range, when you're just subtracting the highest and the lowest, the range of company A's engine is 1,000 miles. The range of company B's engine is 50 miles. That tells me a little more that the company A's engines are less predictable than company B's engines. However, range can be deceiving, because if there was just one outlier, like if we had 1,000 of A's engines and 998 of them lasted 1,000 hours, and one of them lasted 1,500 hours, and one of them lasted 500 hours, you'd still get a range of 1,000 miles. So it only looks at 2 of the data points, and that probably isn't enough to make a decision, because those 2 data points might not be like the rest of the data. But it's a start anyways. It will definitely, this shows me that B's engines are probably more predictable than A's engines, but it's only looking at 2 of the engine lives, and if the engine lives weren't so uniform, it would maybe not lead you to the decision that you want to make. Quick example here, just to get practice with range. Here's a set of data, and I want to find the range of a set of data. To find the range of the set of data, I need to find the highest number, and in this list, the highest number is 30. I need to find the lowest number. The lowest number is 5. The difference between the highest and the lowest number is the range of the set of data, so that would be 30 minus 5, which is 25. That tells me that the data is a bit spread out, and again, not that it's necessary in this section, but if I was asked to find the mid-range for this data, I'd take the lowest set of data number, which is 5, plus the highest number, which is 30, and divide it by 2. I think that comes out to 17.5. So they're not the same numbers, they're not the same computations. Mid-range is an average, range is kind of a measure of spread. Alright, that's the easy. Range is easy. Standard deviation takes into account all the data, and it measures how much the data is spread out. When we compute standard deviation on our calculator is going to come up with 2 different numbers that measures the spread of the data. It's going to give me this symbol and this symbol, which both represent standard deviation. And this symbol right here is, we say it's the standard deviation of a population. And you use this when you know the entirety, the information about every piece of possible data in the sample that, or in the population that you're testing, or in the item that you're testing. And the sample standard deviation is the S. And exclusively we're going to be using this. When a company like, well, let's say, since we're doing engines, something similar, like a company that makes tires, when they sell you a tire and say this tire is going to last 50,000 miles, well, they'll test some tires, and they want their tire life to be predictable, so they'll compute a standard deviation. For them, when they're computing their standard deviation, they're going to use the standard deviation of a sample as opposed to the standard deviation of a population. Because in order to get the standard deviation of a population, you would have to take every single tire that they make and find out how many miles it's going to go for. And when you do that, you destroy the tire, so you can't sell it anymore. So they're just taking a sample of the tires and using that sample to project onto the rest of the tires. Similarly, for our aircraft engines, I say their lives are 500 hours and 1,500 hours, or 925 hours and to 975 hours. but there's no way you would test every airplane engine to get an exact standard deviation. What you might do is take a sample of a few engines and then use that sample to project onto the population. So in our class, when we're doing standard deviation, which is a measure of how spread out the data is, that uses all of the data as opposed to just two of the pieces of information, we're going to use sample standard deviation. And that, again, it's not going to be that important for us. If you take a statistics class, you will get really immersed into standard deviation, and the 30 minutes this morning that I spent talking about standard deviation is going to be expanded into an entire course essentially. So we're just barely scratching the surface. All right, so now we want to figure out how to manually calculate standard deviation. If you don't have the desire to learn how to do this manually, it doesn't make any difference in the world to me. You can fast forward and wait till I break out the, well, I'm going to break out my calculator even when I'm doing it manually, but when I get to I'll put a little mark on it so you could see it. I'm doing 2 examples by hand. So eventually I'll get to this page, and this page and then the next couple is where I'm going to be doing calculator standard deviations, and this is what I expect you to do for the homework and expect you to do on the tests. If you take a statistics class, your teacher will likely let you use some sort of computer program to compute standard deviations, and it won't be the TI-83 or 84 calculator, but it gives you the same number, and this is what we have available to us, and it works just fine. So if you wanted to not watch from here to there, it's not going to hurt you. I'll probably say a few things in there that might have been nice to hear, but it won't keep you from being able to do the homework or do well in the test. So this is the formula that I'm going to use to compute sample standard deviation, and we're not doing population standard deviation. And what I've done on the next few pages is I've made up samples of lives of company A's engines and samples of lives of company B's engines, and I'm going to compute the standard deviation for that sample of company A's engines and for that sample of company B's engines, and I will then do them via my calculator. So this formula is pretty impressive looking, and it's not really even complete. It's a kind of a a baby version of the formula, because it's missing some subscripted numbers and some indices on the notation. This notation is not worth my time talking about, because I've developed a way to compute the standard deviation by hand that uses this formula, but it kind of uses this formula in hiding, in terms of buried inside of a table. So now we're going to do 2 standard deviations by hand, and then eventually I'll come back and do them on my calculators. So let's say I took a sample of company A's engines and a sample of 6 of company B's engines, and just like I thought should happen, half of company A's engines live for 500 hours, the other half 1,500 hours. Half of company B's engines had a life of 925 hours, and the other half 975. Just like I said they would come out, because that's what those companies historically have done. So I would expect standard deviation, the number that takes into consideration all of the data for company A's engine, should be larger than that for company B's engines. And now we're going to do it by hand. So for company A's engines, where half of them did 500 hours, the other half did 1,500 hours, 3 500s and 3 1,500s, how am I going to find the standard deviation? Well, step 1 is to find the mean, or the average. And so I'm going to take the 6 engine lives, and the 6 engine lives were 500, 500, 500, and then 1,500, 1,500, and 1,500. And I'm finding their average, so I add up all 6 and divide by 6, and I get the average life of 1,000 hours. So that's step 1. Step 2, I'm going to take each one of these numbers, the 500, the 500, the 500, the 1500, the 1500, and the 1500, and take it and minus the mean. So this is 500 minus 1000, 500 minus 1000, 500 minus 1000, and then 1500 minus 1000, 1500 minus 1000, and 1500 minus 1000. So I added up the numbers and divided by 6 to get the mean, and now I'm subtracting each of the data points or each of the pieces of information minus the mean. So this is data point minus mean, and I get a string of numbers here. So I'm done with step 1, find the average. Step 2, take each of the numbers and subtract it from the average. Step 3 is to take these numbers, the negative 500, negative 500, negative 500, 500, and square them. So I took negative 500 squared 3 times, positive 500 squared 3 times. So I squared those numbers. I did that on my calculator. So I wasn't going to do that by hand. So to do negative 500 squared, I did negative 500 squared and got 250,000. To do positive 500 squared, I got 250,000. And so I squared each of the numbers, and so those were the numbers that I had in my column. Squared them, and now I'm going to add them up. So then I'm going to add these up. And you can do that on your calculator, just 250,000 plus 250,000 6 times, you'll get 150,000. So step 1 was the mean. Step 2 was each number minus the mean. Step 3 is where we're on now. Square each one of these numbers and then add them up. And that's where I'm at right now, and I'm actually almost done. Step 4 is we're going to take this number, what we got at when we added up the numbers in step 3, which is 150,000. We're going to divide it by the number of data points minus 1. There were 6 data points, so I'm going to divide by 5, and now I'm going to square root that. So I'm going to go second square root of 150,000 divided by 5, close out my parentheses, and it gives me 173.205, and I almost really, really, that certainly doesn't look like that. Well, let me real quickly, so you can't see it, do the standard deviation on my calculator to make sure that this is just a mistake here. And then I don't want to show you yet how to do the standard deviation on our calculator. Should be 547.72. I just did this on my calculator, and not that it matters yet. And let me see what I did wrong here. So clear second square root 150. Oh, I was missing a 0 maybe. Or do I have too many? Idiot. 1512345 So 1, 2, 3, 4, 5 zeros. Divided by 5, boom, boom. I don't know what I did wrong before, but now I just got 547.72 like I'm supposed to get. My suspect is I didn't put enough zeros in. So doing it by hand, it's kind of tedious because I was able to do it off screen on my calculator in seconds. It's tedious and it's easy to make mistakes. So company A's engines have a standard deviation of 547 hours. That's not that good. When the mean life is 1,000 hours and you have a standard deviation of 547 hours, that tells you their life isn't very uniform. Now I'll do one more by hand and then not another one by hand. So I'll do the same thing for company B's engines. So I have 6 of company B's engines. Half of them last 925 hours. The other half lasts 975 hours. I'll do the standard deviation by hand. To do the standard deviation by hand, first I find the average. So I'll take the 6 numbers, add them up and divide by 6. And then again, if you want to do this on your calculator, you'd go parentheses 925 plus 925 plus 925 plus 975 plus 975 plus 975. You'd close the parentheses, and then you'd go divided by 6. You'd get the average life of 950 hours. And then now I'm going to take each one of these numbers, 925 minus 950 3 times, and then 975 minus 950 3 times. So there's 3 925s. I need to subtract the mean of 950. 3 975s. I need to subtract the mean of 950. So that's my end of my step 2. My step 3 is going to be to square all these and add them up. So first I found the average, then I took each number, each data point, and subtracted it from the average. And now I'm going to square each one of these numbers. So step 3 is to take each one of these numbers, negative 25s, the 3 negative 25s, and the 3 positive 25s, and I'm going to square them. And after I square them, I'm going to add up the numbers. I'm almost done once I do that, because the standard deviation is going to be the square root of that divided by 1 less than the number of data points. There's 6 data points. The formula tells me to divide by 5. So the standard deviation, I'm going to go second square root, second square root of 3750 divided by 5, and I get 27.39 for the standard deviation. So it's more than 25 hours, even though each engine is kind of 25 hours from the mean. The standard deviation, it gives you a slightly bigger number than that. So for company B, its standard deviation is 27.39 hours. So if you compare the 2 engines, A's engines last 50 hours longer, but they have a standard deviation of 547 hours, and B's engines only have a standard deviation of 27.39 hours. So possibly B's engines are better than A's in some sense for a consumer because they're more predictable. So the standard deviation shows a difference at the mean. Just can't show. All right, now by calculator, and I will not do a standard deviation by hand again. It's going to be 100% calculator standard deviation from here out. And again, if you want to do them by hand, you can do them by hand. So, how do I find the standard deviation for company A's engines? And remember, this standard deviation should equal, so S, and my calculator gives it an S sub x, which means standard deviation of the x data is going to be 547.72 hours. So how am I going to get that? I'm going to need to go through steps, and the first time or two that I go through the steps, it might feel tricky. So I'll try my best to make it work okay. So first thing I'm going to do is hit my stat button. So my stat button is, let me blow this calculator up as big as I'm comfortable getting it. So first thing I'm going to do is hit my stat button. So I should probably just leave a page here. So steps first. I'm going to hit the stat button. And the stat button is, let me clear out the main screen so that you don't see anything there. So I just hit the clear button. Now I'm hitting the stat button. And when I hit the stat button, my calculator comes up and both the number 1 and the edit column is highlighted. And that's what I want to have on the first step. So I'm going to select option 1 that says edit. And because I just did this problem, when I bring up my edit screen, you're going to see the data already in. I'm going to delete it so I'll type it in. So now I'm going to hit the enter in the bottom right hand corner of my calculator. So after I hit edit, or after the edit and the one are highlighted, then you hit enter. So really for now, you're just hitting stat and enter in your first step. So let me just second quit. So I'd go stat and then enter. And that'll bring me to a screen where I can enter my data. I need to enter my data in L1. And I've already entered my data in L1. And you may have no data there, which would be nice, or you may have data there. What you can do now is just delete each piece of data. I can just go delete, delete, just hitting the delete button, and it's taking the data away. There's other ways to delete the data, but this is probably as easy as any. I just have my data highlighted and I hit the DEL key. So now my list 1 is completely blank, and I want to enter the engine lives. Well, there 3 engines had a life of 500, 3 had a life of 1500. So I'm going to enter the data now. So I'm going to clear out list 1. I don't care if there's numbers in list 2, list 3, list 4, it doesn't matter. I'm only working with list 1, and now I'm typing the numbers 500 and then hitting edit, enter, 500, hitting enter, 500, hitting enter, and then 1500, enter, 1500, enter, 1500, enter. So I have my data in. Just in case I went too fast, let me do this again. So second and quit gets me back to the main screen. I would go stat and then enter and then delete, 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 and then enter the data. 500, enter, 500, enter, 500, enter, 1500, enter, 1500, enter, 1500, enter. So I'm done with step 1. Now for step 2, I'm going to hit the stat button again. I don't even have to hit second and quit. So I'm going to hit the stat button again. And now I want to have calc in the middle column highlighted and one variable stats in the numbered columns highlighted. And I got that pretty quickly. If I just hit the stat button, it takes me to that screen. If I just arrow over once, it does everything that I need. It has the calc highlighted and it has the one variable stats highlighted, and we're almost done. Now we just hit enter twice. So I'm going to hit enter once and then enter twice. The number that we need is the number next to the SX, means standard deviation of the X data, and it gives me 547.72 is exactly what I said it should be. 547.72 is the standard deviation of the engines, the A engines. So that's A engines using my calculator. Now I'm going to do the same for the B engines. So to do a standard deviation for the B engines, and there's the lives of the B engines, I'll go through the steps. So first step to find the standard deviation of the B's engines is hit the stat button. So first, I'm going to hit the stat button. So I'll just hit the stat button and then enter. So first step is a stat and enter, and then a bunch of deletes to get rid of all the data. So now I'm going to hit delete once, twice, 3, 4, 5, 6. All of the A data is out of list 1. And my list 2 and list 3, I don't really use that often. That's why there's nothing in them. And now I'm going to enter the data. So 925 hours, enter, 925 hours, enter, 925 hours, enter, 975, enter, 975, enter, 975, enter. So I hit stat and then enter. I deleted a bunch of times, and then I entered the data. Once the data's in, so that's the first step. Once the data's in, you hit the stat button, you arrow over to calc, and you hit enter twice. So almost done. So again, just to walk through this, I did stat, enter, delete, 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 and then 925, 925, 925, 975, 975, 975, and then last I go stat, use the right arrow button to go to calc, and hit enter twice. Enter, enter, and the number next to the S is the one we want, 27.386, and that rounds to 27.39. So I won't do any of the grunge by hand because it's just not necessary. All right. And then this page here is just something I typed up, and again, it's just to try to illustrate the importance of standard deviation, and especially in a business, profits setting. So, like if I buy a box of cereal that's supposed to contain 20 ounces, I want 20 ounces in it. And it's not that I'm going to measure it, but if I bought a box of cereal that's supposed to have 20 ounces and it has 15 ounces, well, I might be able to tell that that's short because I'm used to what a 20-ounce box of cereal feels like, and as a consumer, I'm not going to be happy if I'm not getting all the cereal that I'm paying for. So for me, if my 20-ounce box cereal has 16 ounces of cereal, I wouldn't be happy at all. If it had 23 ounces of cereal, I'd be happy. On the other hand, if you're the business owner, you don't want to get customers mad at you, so you don't want to ship out a box that has 16 ounces and say that it's 20 ounces. In fact, you probably can lose a lawsuit if you did that consistently. So you can't go short because you're just gonna not make your customers happy. But if you start going over, if you say you're selling 20 ounces of cereal and you're giving 23 ounces every time, well, you're giving away stuff for free essentially. Somebody that's buying a 20-ounce box of cereal, they only expect to get 20 ounces, and if you give them 23 ounces, that's like 15% more cereal than you promised them. And if you give them 15% more, it's costing you probably 15% more money, and you're cutting into your profit margins. So your standard deviation, when you're producing a product, you probably want the standard deviation of the amounts of the product to be relatively small, based on what your consumers, if you're selling it, expect, and that still keeps your profit margin intact. That's probably good enough for this. Now we can do homework, and the beautiful thing is the homework's going to go really fast. We're going to rip through our calculator. For each of the first 6 problems, we want to do the range and the standard deviation. So I'm going to start off with number 2, and I'm going to do the range. Range is just high minus low. And in my problem, the data is ordered. The high is 15, the low is 3. So in problem 2, the range is going to be 15 minus 3, which is 12. Halfway done with the problem already. That's the easier half, but not much easier. And then the rest of what I want to do is the standard deviation. So I'm going to go through and do the standard deviation on my calculator. So break my calculator out, hit the stat button, hit enter, and then delete, 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 delete. Now enter the data. 3, enter, 5, enter, 7, enter, 9, enter, 11, enter, 13, enter, 15, enter. Data's in. Once the data's in, you hit the stat button, arrow over to calc, and hit enter twice. It actually gives you the mean. The mean is 7. It gives you numbers that we don't need, and it gives me the S sub x, which is the standard deviation, which is 4.32. It actually gives me the population standard deviation as well, and it gives some more information that I don't need to. So standard deviation for this problem for me is going to be 4.32. I can't attach any units to that because the numbers don't have units. All right, problem 4, and you can do 3. The range for problem 4 is the highest number 92 minus the lowest number 1. which is 91. And then for the standard deviation, I don't need to order the data. It's okay to put it in an odd order. I'm not going to take the time to reorder it. So for standard deviation, I hit my stat button, then I hit enter, and then delete a bunch of times. Now I'm going to enter the new data. 1, enter, enter, 3, enter, 71, enter, 8, enter, 92, enter, 63, enter, and then stat, bump over to calc, and enter, enter, and then my standard deviation is 40.267. I'm going to round that to 40.27. I'm sure my instructions said round to 2 decimal places. So I got 40.267 for the S of x, and I'm going to round it to 40.27. All right, number 6, and you can do number 5. Number 6, I'll do the range. The range is the high, 13, minus the low of 0. It's 13. And then I'm going to use my calculator to do the standard deviation. So first thing to do my standard deviation is I hit the stat button and then enter, and then a bunch of deletes. Delete, 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 delete. All the stuff is gone. Now I type in 0, enter, 3, enter, 5, enter, 9, enter, 9, enter, 10, enter, 11, enter, 13, enter. Data's in. Hit the stat button, arrow over to calc, and hit enter twice. And I get 4.4, and then 0.7, that 7 tells me to round the 0 up to a 1. I'm going to write 4.41 for my standard deviation. 4.41. So that's about as easy as it gets. And we have a word problem that in some sense there isn't, well, there aren't right or wrong answers for part C. So for part question 7 that you get to do, and I'll do one like it when I do question 8, we have a restaurant that sells steaks, and they have some of their steaks are 12-ounce portions, and we looked at a couple of cooks and they had to cut the steaks themselves, and we want, of course we want the same thing. We don't want the steaks to be too big because we're paying, we're paying for that, and we don't want to have our costs be more than they should be, but then again we don't want the steaks too small because people will be upset. So for Opie and Opie from the Andy Griffith Show, not that any of you know what that is, and Maynard from a show called Dobie Gillis that was like in the 50s. Anyways, Maynard was played by Gilligan. I don't know who he is either. Nevertheless, the first thing I want to do is find their mean portion size. So for Opie, you're going to add up his four steaks that they sampled and divide by 4 to get his mean size. For Maynard, you're going to add up his 4 steak sizes and divide by 4 to get his mean size. And then you'll do the standard deviation for each. You do Opie's standard deviation and Maynard's standard deviation. And then looking at their means and their standard deviation, you're supposed to decide, which of these guys, from your perspective, would be the guy that you'd want to cut the meat. And I mean, just by glancing at it, it looks like Maynard's the better one, because if I'm cutting a 12-ounce portion, most of his are close to 12 ounces, whereas Maynard has a really big one and a really small one. And Opie has a really big one and a really small one. You probably wouldn't want Opie, but you can do the computations. And if you're not ready to do that, you can watch me do number 8. So I'll read through my problem because I wrote this, probably 2 or 3 months ago, and I don't remember exactly what I wrote. So for a summer job, you're working in the quality control department for a computer company that manufactures computer parts. The specific part you are to evaluate is supposed to be 8 micrometers in thickness. You obtain samples of 4 of these parts manufactured by the day and the night shift. Here are the findings. So the part is supposed to have an 8 micrometer thickness. Looks like the day shift is doing wonderful because they're bunched up around 8. The night shift is doing horrible. First I'm going to do the part A. So I'm going to do the mean thickness for the day shift, which is the average thickness, just like you're going to do the average for the stakes. So the day mean, I'm going to take 7.9 plus 8.0 plus 8.2 plus 8.3 and divide by 4. And then for the night mean, I'm going to do 2 plus 4 plus 12 plus 14 and divide by 4. And so for my answer in part A, I'm going to have a day mean and a night mean. I have to do these with parentheses. So when I break out my calculator, I'm going to just hit clear right now to clear out the screen. And for the day mean, I'm going to go 7.9 in a parentheses plus 8.0 plus 8.2 plus 8.3 parentheses divided by 4. And I get 8.1 for their mean. They're shooting for 8 and they're at 8.1. So the mean seems reasonable. It's a little thick. I don't know much about the part or computers to know whether that's really unacceptable. And then for the night, I'm going to go 2 plus 4 plus 12 plus 14 divided by 4, and I get exactly 8. So by just glancing at the means, the night shift looks better than the day shift. So if that's all you were told, the night shift seems to be doing their job better. But when I look at the data, I can tell that the night shift is way off, out of whack here. And then I'm going to do now the standard deviation of the day. I'm writing SD for standard deviation. And I'm going to do the standard deviation of the night shift. And I'm going to do that on my calculator. So for the day shift, to do its standard deviation, I hit the stat button, I hit enter on edit, and then delete a bunch of times. Delete, 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 delete. Data's gone. Now type in 7.9 and I just can't get this. 8.0, 8.2, and 8.3. Data's in. Hit the stat button again. Arrow over to calc and hit enter twice. And take the S number. And I'm going to get 0.18 for the standard deviation, or 0.18 for the day crew. Because that's this S rounded to 2 decimal places. The 2 in the third position tells me I can leave the 8 alone. Now I'll do the night shift standard deviation. I'm going to hit the stat button and then enter on calc and then delete the data. So delete, 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 delete. And now the night data is 2, 4, 12, and 14. And then stat over to calc and enter twice. The night shift standard deviation, I'm going to round that to 5.89 because the 7 in the third spot tells me to round the 8 up to a 9. So their standard deviation is 5.89. Now I'm ready to answer part C. And this answer was clear to me even before I got started. So I might say day is better because they're more consistent. And in a stats class, you'd have to get elaborate. you'd probably say, even though the day's mean is slightly beyond the 8 micrometers that is desired, their product is more uniform. Their standard deviation of their product is 0.18 micrometers, whereas the night shift has a mean of 8 millimeters, and while this is the desired mean thickness, the standard deviation is 5.89 micrometers, which is maybe beyond the company's acceptable tolerance. I didn't feel like getting that wordy, so I did something in here. But in the statistics class, this would not even be close to acceptable. But in a Math 142 class, when we're just introducing the concept of standard deviation, I think that's completely fine. I think that's everything for this section, and it is. So you should make your best step at doing the homework, and when you get your problem 7, which is your word problem, I got a little wordier here because I can type better than I can write. So again, I use the same word, consistency, I think was the word that I used, and I used it again. And even though I wrote this months ago, I came up back with the same sort of words, and that's not surprising. So when you do your justification for problem 7, who you would pick, again, you could make an argument for either person as long as your argument has some justification behind it. And maybe that case, it's not as clear between Opie and Maynard who's the better steak cutter. So that's that section done. We have 2 more sections in chapter 3, and they're on money and finding out car payments and house payments and doing savings for retirements. And you'll absolutely need this calculator to go through those problems, because without those problems, without the calculator, the problems are a nightmare. The formulas that you need to know are just really